My name is Nikodem Poplawski. I am a theoretical physicist. I received my PhD from Indiana University. Currently, I am a researcher in gravitational physics and cosmology. My research focuses on the origin of the universe, the nature of black holes, and the nature of dark energy. My research was featured in some scientific magazines such as National Geographic, Science, and New Scientist, and very recently I appeared in the Discovery Channel in the program Curiosity and in a program called Through the Wormhole with Morgan Freeman. I am a tutor working for tutorhero.net. Here is our website, and if you are interested in seeing more of our technology or scheduling appointment with me, here's the email, tutor@tutorhero.net. And here are the subjects which I tutor. I'm experienced in multiple subjects in physics, astronomy, and mathematics, such as mechanics and electricity and magnetism, special and general relativity, calculus, astronomy. As an example of showing how unique our technology is, I would like to solve a simple problem in general physics. Here is the problem. A block with mass m is sliding on an inclined plane with angle alpha. Find the acceleration of the block. The coefficient of kinetic friction is mu, and the gravitational acceleration is g. So let me start with drawing the picture. So here we have an inclined plane, and here's the angle alpha, and here we have the block, nicely approximated as a rectangle. So the block is moving along the plane because of the gravitational field. So you write the vector, that's acceleration g, and we like to find out the acceleration a. And the block has mass m. So what should we use? We should use Newton's second law of dynamics. Newton's second law says that acceleration of the body is such that the product of mass and acceleration is equal to the sum of the forces acting on the body. So this is Newton's second law. This is a vector equation, which means we have to project it onto axis. So now, the choice of axis is arbitrary. We could choose axis, x and y, like that, and the z-axis could be pointing to our direction. However, you see that acceleration of the block is along the surface of the plane, and most of the forces will be either perpendicular or parallel to the surface of the plane. Therefore, this is not the best choice for x. The better choice, more natural, is when you draw axis like that the x-axis will be along the acceleration a, and the y-axis will be perpendicular. Okay, so we have the axis, and now we have to draw all the forces to start to use the Newton's equations. So we have the force of gravity, which is mg. Right, it's going downwards. Then the block, if there was no inclined plane, the block would go down. However, the block does not want to go down because there is the force of reaction coming from the plane. The plane prevents the block to go through the plane, which means that the surface exerts on the block the force of reaction, which is called normal force, which is N, right? So this is like normal force of reaction from the plane. And mg, yeah, I should probably say here, mg is gravity. Also, I mentioned that in the problem there is the coefficient of kinetic friction. So friction opposes the motion. So the block wants to go down and to the right. Therefore, there is the force of friction which slows down the block. So here's the force of the friction. Let me call it F with little f, force of the friction. So those are all the forces. Okay. So what we have to do now, we have to project Newton's equation into the two axes. So let me actually move the axis a little with the what color we can use. I can use maybe again red color here, right? So here we have y-axis, we have x-axis. Okay, so now we project the Newton's law. So let's start with y-axis. So the Newton's law on the y-axis, so you see that ax is equal to a because the acceleration is in x direction. Ay is equal to 0 because there is no acceleration in one direction, right? That's why we chose the axis in the this way we chose them. So max is equal to sum over all f-axis. Now, what forces are in x-axis? Well, there's also another thing we have to do. We have to project the gravity force on two axes. So we have the component of mg on the x-axis. Here's the angle alpha. So you see that this projection is equal to mg times cosine alpha. And there is also the projection of the gravitational force in the x direction, which is here. And this is equal to mg sine alpha. So now, the sum of the forces acting in x direction, you see that there is mg sine alpha. And we have also the purple force, which acts to the left and up. This is minus f, the friction. So those are all forces in x direction. In the same way, may, and we know that of course max is equal to ma because of the here, right? The whole acceleration is in x direction. For my, we have what forces are in y direction. There is the normal, and it is in the positive direction of y-axis, and the green force right here, this force, which opposes, it's against the y direction, so it is equal to minus mg cosine alpha. And we know that this is 0 because ay is 0. So now we have two equations. We have two equations here. So let me put them on the next whiteboard. So ma is mgc minus yeah. So when we go to the whiteboard, we have the same equations written as ma is equal to mg sine alpha minus friction, and we have the 0 was equal to n minus mg cosine alpha. The last equation we have to solve is, we have to write is, what is force of friction? We know that force of friction is equal to coefficient of kinetic friction times the reaction. That's a phenomenological law. So from this equation here, we can write that n is equal to mg cosine alpha. And now we can substitute to the equation for F of friction to get that force of friction is equal to mg mu cosine alpha. And now, knowing this, we can substitute this to the equation for A, and we get ma is equal to mg sine alpha minus mg mu cosine alpha. And when we divide this equation by m, we get the final answer. Our acceleration is equal to g times sine alpha minus mu cosine alpha. Here is our acceleration of the block sliding down an inclined plane. And here again, there is the email tutor@tutorhero.net.